Hello students, welcome to EPG Pathshala. I am Gaurav Gupta from Sharda University. Today we are going to talk on module scheduling, importance and methods in manufacturing from paper operations management. This chapter would help students to understand importance of scheduling jobs in manufacturing operations, different cases of scheduling, priority criteria of scheduling, scheduling various jobs on single machine, scheduling various jobs on two machines, scheduling various jobs on more than two machines. Scheduling refers to assigning sequence of jobs to various machines involved in manufacturing process. For instance, one part of dressing of a doll is to wear pants, wear socks, and wearing of shoes. Three machines, each doing one kind of job, namely, machine 1 is used for wearing of pants, machine 2 for wearing of socks, and machine 3 does wearing of shoes. Also, there are three dolls A, B, and C to be dressed. Figure shows the process when all three dolls are same and they undergo same process of dressing up. A decision has to be made about the sequence in which dolls should enter the system. In this case, as all dolls are same and adopt same procedure, so sequencing might not be that difficult. But sequencing becomes difficult if products require different operations. Figure shows such a scenario when three dolls require different processes to get dressed. In this case, A and B adopts a sequence of pants, socks, shoes, whereas C adopts socks, pants, and shoes, as shown by line curve. Now first question is, out of A and B, which doll should enter the process first? Suppose A enters the process first and takes 30 seconds for wearing pants, followed by V, whereas the same time C is assigned to machine 2 of wearing socks, which takes 20 seconds. Now after 20 seconds, doll C gets free and waits for machine 1. Should machine 1 be assessed by doll C after A gets processed on it, or should it wait for processing of both A and B? If it waits only for completion of A, then waiting time is 10 seconds. Whereas, if it waits for both A and B, then waiting time increases to 50 seconds.
Can see the figure. Machine A, B and C goes to machine 1, 2, 3, and A and B go to machine 1 to 2 to 3, or if C can go from 2 to 3. Imagine the scenario when number of dolls to be dressed increases. Thus, scheduling or sequence of assigning of jobs become important, and it predominantly depends upon sequence of processing. In doll example, sequence can be pants, socks, shoes, or socks, pants, shoes. Sequencing problem increases if variety of jobs asks for different operations. Variety of jobs increases in batch production system. In mass production system, as in car wash example, where each car goes through same process of washing, rinsing and drying, variety of operations is minimal. Thus, assigning of jobs is much easier in mass production system as compared to batch system. Number of jobs to be processed. A batch system of production is characterized by variety of jobs, each being produced at low volume. Each job would be different in terms of sequence of operation and processing time taken at each machine. Cake manufacturing is an example of batch system of production. A chocolate cake is different from a vanilla cake in terms of raw material and sequence of operation used on same machine. Processing time of each operation of each type of cake would be different. Also, variety of operations impact setup time. Machines to be prepared for different operations for different cakes, increasing waiting time and decreasing productivity. Thus, variety of jobs using same machines but in different sequence increase scheduling problem. Number of machine used in processing. If operating system has only one machine in the system and all jobs need to be processed on that machine, then scheduling requires assigning of jobs to that single machine. But generally, one machine cannot carry out all operations. So a job might use multiple machines before getting completed. A manager has to deduce whether operations can be clubbed together and performed on a single machine, or is operations are so different that they would be processed on different machines. Multiple jobs being processed on a set of similar multiple machines is another variant of scheduling being discussed. Taking into consideration above discussed decision points regarding multiplicity of jobs, machines, and their sequence of operations, scheduling can be categorized as workforce and operation scheduling. Determining which employee work when is called as workforce scheduling. Should a worker be assigned night shift or day shift? Which employee should be asked to work on which airline route? Such questions are answered in workforce scheduling. Other type of scheduling studies: assignment of jobs to machine or workers to jobs. Such scheduling is called as operation scheduling. This chapter discusses various quantitative methods of assigning jobs to machines. Scheduling problems. Following are different types of sequencing cases have been discussed in this chapter. Scheduling of n jobs on single machine, scheduling of n jobs on two machines, scheduling of n jobs on more than two machines, scheduling of two jobs on n machines.
Scheduling of n jobs on single machine. The operations using general purpose machines generally use single machine for operating different jobs. For instance, a drilling machine might be used to drill different size of holes in different wooden cardboards. Then if there are 5 different holes to be drilled in 5 different cardboards, then it has to be decided out of these 5 jobs which cardboard would be processed first. Then in what sequence other would follow. Such cases can be resolved by using either of following two priority criteria. Earliest due date rule EDD. In this method, job which has to be dispatched or supplied to the customer at the earliest is processed first. Other jobs are also arranged according to the criteria. Shortest processing time rule SPT. In this method, job with shortest processing times enters the operating system first and then other jobs follow according to the processing time.
These priority rules have been explained by following examples. Table shows processing time and scheduled supply time to the customer of 5 cardboards requiring different drilling operation on same drilling machine. Sequence the job based on EDD rule, second SPT rule. Cardboard 1 processing time 8 hours, scheduled supply time 10 hours. Cardboard 2 processing time 6 hours, scheduled supply time 12 hours. Cardboard 3 processing time 15 hours, scheduled supply times 20 hours. Cardboard 4 processing time 3 hours, scheduled supply time 18 hours. Cardboard 5 processing time 12 hours and scheduled supply time 22 hours. EDD rule. The sequence of jobs processing depend on time required by supply to the customer. Cardboard 1 is to deliver at the earliest, so it would be processed first, followed by cardboard 2 and so on. The complete sequence of the operation would be cardboard 1, 2, 4, 3, 5. By using identified sequence, calculate the waiting time of each job. Cardboard 1, start time 0, processing time 8, end time 8, supply time 10, waiting time 8 minus 10 equal to minus 2. Cardboard 2, starting time 8, processing time 6, end time 14, supply time 12, waiting time 14 minus 12 equal to 2. Cardboard 4, start time 14, processing time 3, end time 17, supply time 18, waiting time 17 minus 18 equal to minus 1. Cardboard 3, start time 17, processing time 15, end time 32, supply time 20, waiting time 12. Start time 32, processing time 12, end time 44, supply time 22, waiting time 44 minus 22 equal to 12. Cardboard 1 enters processing system at the earliest, so its starting operation time is considered as base time. Thus it starts its operation at 0 hours. It takes 8 hours to get processed on single machine and then gets out processing system. So machine becomes free to process cardboard 2 after 8 hours. It takes 6 more hours for processing. Cardboard 2 gets out of processing system after 8 hours. Waiting time plus 6 hours processing time, that is 14 hours. Similarly, other job start and end time is calculated. Now supply time is of cardboard 1 was after 10 hours, but it got processed after 8 hours, so the job supplied to the customer 2 hours early. Thus, negative sign indicates job being processed before supply date. In this example, job 1 and 4 are supplied before due date. SPT rule. The sequence of jobs depend upon processing time taken by each job. Job which takes least time on machine would enter system first and then other would follow. By using this criteria, sequence of job is cardboard 4 2 1 5 3. The table calculates time of job has to wait before getting processed. Cardboard 4, start time 0, processing time 3, end time 3, supply time 18, waiting time becomes 15. Cardboard 2, start time 3, processing time 6, end time 9, supply time 12, waiting time becomes minus 3. Cardboard 1, start time 9, processing time 8, end time 17, supply time 10, waiting time becomes 7 hours. Cardboard 5, start time 17, processing time 12, end time 29, supply time 22, waiting times become 7. Cardboard 3, start time 29, processing time 15, end time 44, supply time 20, waiting time becomes 22. By using SPT rule, cardboard 4 enters the system first and takes 3 hours for processing. It has to be delivered after 18 hours, but is delivered only after 3 hours. Similarly, waiting time for the other jobs is also calculated. Important point: by using same total time to process 5 jobs, that is, make span is same of 44 hours. Which method is better? Average job flow time in case of EDD is 23 hours. Average job flow time in case of SPT is 20.4 hours. As average time for processing 5 jobs by using SPT rule is lesser than EDD rule, so sequencing should be done using SPT rule.
Scheduling of n jobs on two machines. Assumptions. Several jobs are arranged in a sequence to be operated on two machines. It is assumed that all jobs are operated on two machines. Machines are arranged in a sequence. For instance, suppose there are two machines A and B. According to technological sequence, machine B is placed after machine A. A particular job then enters the processing system by going first through machine A and exit after getting processed at machine B. Steps in sequencing. The sequencing of several jobs on two machines is solved by using Johnson's rule, which is based on shortest processing time rule by following given steps. Step 1. List the processing time of each job on each machine. Select the lowest processing time. If selected lowest processing time is for the first machine, then that job is processed first. But if shortest processing time of the particular job is for second machine, then that job is processed last. In case of a tie, job is processed first. Step 3. Repeat above steps and schedule all the jobs.
Example: for the following data given in the table, sequence the operations and calculate their waiting times. Job A, processing time on machine 1 3, processing time on machine 2 2. Job B, processing time on machine 1 6, processing time on machine 2 8. Job C, processing time on machine 1 5, processing time on 2 6. Job D, processing time on machine 1 7, processing time on machine 2 4. Step 1. Select the shortest processing time from the table. It can be seen that SPT is 2 minutes. Select SPT is for job A, so it would be processed last. Step 3. Repeat the process after scheduling A. Out of remaining jobs, SPT is for job D, which is for minutes. This would be processed again last but before A. Job C has SPT of remaining jobs. As it is for machine 1, so it would be processed first. B would occupy the only remaining second position. So final sequencing order would be C, B, D, A. Calculation of waiting time for each job. Job C, start time 0, processing time 5, end time 5, start time 5, processing time 6, end time 11. So waiting time for machine 1 is 0, machine 2 is 5. Job B, machine 1, start time 5, processing time 6, end time 11. Machine 2, start time 11, processing time 8, end time 19. So waiting time for machine 1 is 0, machine 2 11 minus 11 0. Job D, start time 11, processing time 7, end time 18. Machine 2, start time 19, processing time 4, end time 23. So waiting time machine 1 11 minus 11 0, machine 2 19 minus 19 0. Machine 1, job A, start time 18, processing time 3, end time 21. Machine 2, 23 start time, processing time 2, end time 25. Waiting time machine 1 18 minus 18 equal to 0, machine 2 23 minus 23 equal to 0. Job C enters the operation system and gets processed at machine 1 for 5 minutes. For same time period, machine 2 remains idle waiting for job C. When job C gets finished after 5 minutes, next job, that is job B, enters the system. So machine 2 does not have to sit idle or wait for next job. Machine 2 gets free after processing job C after 11 minutes. But at same time, job B gets processed from machine 1 and is ready for processing at machine 2. Total flow time taken to process 4 jobs on 2 machines equal to 25 minutes. Machine 1 gets free from processing 4 jobs after 21 minutes, but job is still in the system and is getting processed at machine 2. So total waiting time for machine 1 equal to 25 minus 21 equal to 4 minutes. Total waiting time for machine 2 equal to 5 minutes. Following table shows processing time in minutes of 4 jobs to be processed on 4 machines A, B, C and D. All these machines are arranged in sequence A, B, C, D. Also, a job has to be adopt this sequence to get processed fully. Find the sequence of job and idle time for each machine. Machines, jobs 1, 2, 3, 4. Machine A 58, machine B 14, machine C 14, machine D 48. Job 2, machine A 30, machine B 10, machine C 18, machine D 32. Job 3, machine A 28, machine B 12, machine C 16, machine D 44. Job 4, machine A 64, machine B 16, machine C 12, machine D 42.
Converting into 2 machines and n jobs. Step 1. Find minimum processing time on first machine, machine A. and last machine, machine D. In this case, minimum time on machine A is 28 minutes and on machine D is 32 minutes. Step 2. Find maximum processing time of remaining machines. In this case, maximum processing time on machine B is 16 minutes and on machine C is 18 minutes. Step 3. If minimum time on first machine, that is A, on last machine, that is D, is greater than maximum time of remaining machines, that is B and C, then machines can be clubbed together. In this case, minimum A equal to 28 is greater than maximum B and C, that is 16 and 18 minutes. Minimum D equal to 32 is greater than maximum B and C, that is 16 and 18 minutes. Step 4. Now, the problem can be converted into 2 machines and 4 job problem by the processing times of B and C are added to that of A to create an imaginary machines P. Also, processing times of B and C are added to D to create an imaginary second machine Q. Step 5. Scheduling of n jobs and 2 machines now can be solved by using Johnson's rule.
Machine P processing time, Q processing time. Job 1 58 plus 14 equal to 86. Machine Q 48 plus 14 equal to 76. Job 2 machine P 58, machine Q 60. Job 3 machine P 56, machine Q 72. Job 4 machine P 92, machine Q 70. Sequence of jobs to be processed on machine P and Q based on SPT would be 3, 2, 1, 4. Calculation of waiting times for all machines shown in table. Machines A, B, C and D. Job 3, 2, 1 and 4. Job 3 machine A start 0 and 28. Job 3 machine B start 28 and 40. Machine C start 40 and 56. Machine D start 56 and 18. Job 2 start 28 and 58. Machine B start 58 and 68. C 68, 86. D start 800 and 132. Job 1 machine A start 58 and 16. Start 116 and 130. Machine C start 130 and 144. Machine D start 144 and 192. Job 4 start machine A 116 and 180. Machine B start 180 and 196. C start 196 and 208. Start D 208 and 250. Total idle time for machine A is 250 minus 180 equal to 70. Total idle time for machine B equal to 28 plus 18 plus 48 plus 50 plus 250 minus 196 equal to 198. Total idle time for machine C is 40 plus 12 plus 44 plus 52 plus 250 minus 208 equal to 190. Total idle time for machine D equal to 56 plus 0 plus 12 plus 16 equal to 84. Total flow time or time taken to complete processing of given number of jobs equal to 250 minutes.
So students, let us summarize what we have learned in this module. Scheduling of jobs becomes immensely important aspect in operations management if a firm is involved in manufacturing variety of jobs using multiple machines. Batch shop production system, which is characterized by general purpose machines used to manufacture high variety of jobs at low volumes, asks for assigning sequence of each job on different machines. The solution of scheduling problem carries importance as it directly impacts waiting or idle time of machines. Machines sitting idle for longer period of times have determinantal effect on efficiency of operations. Three scenarios of scheduling have been discussed in this chapter. Processing of variety of jobs on single machine, processing of variety of jobs on two machines, and processing of variety of jobs on more than two machines. Scheduling of jobs in each case is done on certain priority criteria. Two criteria, namely shortest processing time and earliest due date, have been discussed. Predominantly, a criteria of shortest processing time is used in sequencing of jobs. Illustration of all the cases discussed have been done on criteria of SPT. Thanks.